with that, Kevlin.
Right, okay. Okay, so good evening. You'll notice that there is a strange yellow tint. That's nothing to do with me, that's everything to do with all of the other equipment. But I can tell you the slides are in glorious full colour. At least they are on the screen. So I want to talk about objects and particularly misunderstandings. It's a relatively any paradigm is relatively deep, and unfortunately when something becomes popular we end up with a really superficial understanding of it. What normally happens is you take a good idea and to make it popular you spread it out, and what happens is as you spread something out it becomes thinner and the original essence is lost. So I have a lot of people going around going, oh, you know, objects, they're so, you know, yesterday and they're no good for anything. Well, they're not good for everything, but they're good for some things, if only we knew what they were. Okay, so a couple of things. I'm easy to stalk on Twitter. It's not a spelling mistake, it is Kevlin Henney. I have a long-standing interest in patterns, and that's actually one of the reasons I'm quite interested in how people approach different problems from different perspectives using different design structures, different styles, because each one affords or allows us a different approach to a solution. So that's that. What else? 97 Things Every Programmer Should Know is a book that I edited a few years back. We're actually now going to start working on 97 Things Every Java Programmer Should Know. To get a bit more specific though, when we use the term Java there, we're talking about the whole ecosystem, not simply the language. But let me just wander off to something else. One of my hobbies, as you might be able to guess, is I like taking photographs of books. I've got quite good at taking photographs of books, and here I have a crowd of books that I took a photograph of. I have an interest in words and language, and I run a page on Facebook, Word Friday, in which I publish various word and language related links, and every Friday I normally publish an unusual word along with its definition. And so what we're going to find out is that this obsession runs through a few of the things that I talk about, because I'm very interested in words and how they're formed. So I want to start off with a little bit of linguistics. I want to talk about agglutination. As the Wikipedia entry on this one says, it's a process in linguistic morphology derivation. If nothing else, you can go into work tomorrow and use that phrase with confidence. Oh yeah, linguistic morphology derivation. That's what, you know, it's not just a joke. You know, this is serious stuff we do here. In which complex words are formed by stringing together morphemes, basically sound elements, meaning elements, each with a single grammatical or semantic meaning. Languages that use agglutination widely are called agglutinative languages. Okay, so a lot of languages have at least some agglutinative characteristics to them. And it means you can just glue words together. Here's a good one. I'm not going to try and pronounce. No, maybe I'm. Hippopotamonstrosequipedaliophobia. The fear of long words. It's beautifully self-referential. It's taken by sort of gluing together a whole bunch of words. The longest word in the English language, and I really am not going to pronounce this one, is this one, which is ironic because there isn't a single English element to it. It's all Greek and Latin. But it refers to a pulmonary or lung condition that you might get by inhaling particles of smoke or sand. And this word is interesting because it was made up to be the longest word in the English language. Somebody sat there and said, okay, what can I do? Now we move on to the serious territory. Although English is a Germanic language historically, it doesn't show it as much these days. You've got to go to Norway to get a good word like this. And where you find long words is normally in government and bureaucracy and administration. And this is to do with a traffic regulation. Again, I will not pronounce this. And obviously, normally the record for this kind of thing goes to German. I think that's 64, 65 letters long. Now, there's an interesting question. Is this still a word? Because it actually refers to an EU directive that was retired about 4 years ago. In its abbreviation, this word is 12 letters long. Okay, but you just keep on adding things together. But actually a true agglutinative language, you find something like Turkish. This word, I'm really not going to pronounce that one. And it's actually made up by somebody who was trying to make up the longest word in Turkish and use it in a book, which they did. You know, I'm pretty sure that whoever was responsible for printing that book hated them, because, like, you know, how do you get this beautifully justified on the page with any other words? So why is all this relevant? Why am I showing you this? Because this is how a lot of people think object orientation is. A lot of people, they come to it, I'm going to say Java came along and it completely screwed up the good work that was being done in the object world. It came along and people started thinking, oh, the way we create objects is we use classes, and the classes have simple responsibilities, and these responsibilities are managers or controllers or something like that. And what we do is we just, if you want to describe your meaning, you just glue lots of words together. And if you really want to confuse people, you glue more words together. Now what's funny is that people think, oh no, I'm going to make this more meaningful. I'm going to add more things. No, 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 no. You make it less meaningful by adding more. It's diluting, okay? If I take whiskey and I put water in it, you have, well, it's still whiskey, but it's just not as strong. If I put more water in it, I'm using whiskey because I was in Edinburgh last week and there was a whiskey tasting at the conference that I was at. And if I put more water in, does it make it stronger, more meaningful, more potent? No, it just makes it more like water. So I want you to think that next time you go and think, I've got a standard component I'm going to add to my name, and I'll just add I'll extend the meaning. No, you won't. You'll dilute it. Because naming is hard. We see things here. Thirst quencher container. Multi-but supporter is one of my favorites here. You know, but this is an object-oriented programmer. How would an object-oriented programmer really look at this? Well, they're going to look at it completely differently. They're going to look at this and they're going to say, well, you know, that's a door. That's a Venetian blind. That's a television. The only thing that even remotely looks the same but doesn't quite work out in this colouring is the television remote control. It's a similar length to entertainment provider visual controller. It even uses the word control, but that's because we use that in the real world. It turns out that sometimes the whole point is to name it what it is. That's the idea. The idea of the object paradigm was to look at the model world, look at the concepts that you wanted to place in your program, and name them that way. Not to kind of add, no, I can't call it that. Sometimes I see people looking at names, looking a little uncertain. Well, it's too obvious. It's too simple. I need to add things to make it sound more technical. We end up with a style, you know, we end up with a style that moves away from what we want to say. This is a book. One of my other interests is actually writing short fiction. And this is an interesting book I came across recently, Robert McKee's story. It's about screenwriting, and in it he describes a number of things, a number of techniques, a number of observations, very useful if you want to watch a film actually, as opposed to just write one. But he talks about story, and he just makes this very simple observation. Nouns are the names of objects. Verbs, the names of actions. That really is it. To write vividly, in other words with life and with colour, avoid generic nouns and verbs with adjectives and adverbs attached, and seek the name of the thing. This is what writers do. And when you are writing code, this is one of the things you should be doing. Now, of course, it's always going to be hard working through a second or third language, but it turns out naming's hard whatever language you use. Naming is hard because what you're trying to do is get to the essence of something. You're actually trying to describe what it is, and that's actually surprisingly hard, because you're trying to understand. If you like, code is an expression of knowledge. It's a structuring of knowledge. And you don't always know what you know. You don't know it until you try and say it, and then you realize how hard it is. That's why any paradigm is hard. A lot of people, I'm also very interested in a lot of functional approaches, and I see people wandering over to functional programming, having already screwed up object-oriented programming, and they're now busy screwing up functional programming because they're choosing bad names. They've got all, it turns out it's hard. They're trying to identify abstractions. That does not change. The style of identification is what differs. Now, this stuff is not new. This is a great book by Ken Beck, Smalltalk Best Practice Patterns. Does anybody actually use Smalltalk in here? No, so, okay, right. This is not surprising. It is not a mainstream language anymore. In fact, it never really was a mainstream language. We just wanted to be a mainstream language. However, it is one of the kind of the granddaddies of object orientation. It is one of the most influential languages. And It's also a great little patterns book. It deals with very little detail patterns as well on your coding style. And this was published in the mid-1990s, 97 I think. And Ken made a number of observations in it. Just I'm talking about the naming. He says, people will be using the words you choose in their conversation for the next 20 years. This is kind of interesting because we're now at that point. We're almost at 20 years after this book was published. You want to be sure you do it right. Unfortunately, many people get all formal. Just calling it what it is isn't enough. They have to tack on flowery, computer sciencey, impressive sounding, but ultimately meaningless word like object, thing, component, part, manager, entity, or item. Now I want you to keep in mind that this book was published in 97. I actually found a draft of the book dated 1995 online. So sometimes, although I'm kind of joking and say, oh, Java came along and screwed it up, actually no, it didn't. This was going on everywhere. My dislike of putting the word get in front of everything, I found an article that I wrote in 1995 concerning C++, and I was already complaining about this really stupid habit people had of putting the word get in front of things. It's just like, no, it's not get. You know, we don't get things. If you get something, you have a side effect. You know, that's what get means in English. It means to change something. It does not mean to ask a question. That's, you know, so you know, this misuse of language was already happening. Okay, nothing new. It's just there's a lot more people doing it now. So this kind of style gets really popular, and this is why, you know, it's so popular. It's kind of gluing together the name style. We even have websites devoted to this. Classnamer.com. You can just hit the refresh button, and it'll generate a new name for you. And I had to take a screenshot when it came up with temporary lolcat selector. I thought that's brilliant. This was such an inspiration. Jeff Foster went off and did the method version. So basically, you've now got your whole program sorted for you. You've got the class namer, and you've got the method namer. You can now just sit there and just like, yeah, yeah, that's a good name. Copy, paste, done. Yeah, and this is how you can generate large enterprise systems. Yeah, you don't need to be involved except as a copy and paster. So what we've actually ended up with is not object orientation. We've ended up with something called managerialism. Now that's not actually a recognized term in software development, but I stumbled across it a while ago in the dictionary. By the way, I don't just sit there reading dictionaries, but that can be interesting. Managerialism, it turns out there's a word for it. Belief in or reliance on the use of professional managers. Application of managerial techniques of business to the running of other organizations. Belief in the importance of tightly managed organizations, as opposed to individuals or groups that do not resemble an organization. In other words, all this stuff, what we end up with is a lot of objects that seem to be torn between one of two roles. Either they manage everything, they're controllers, they're called managers, they're processors, they're handlers, they're any one of these standard suffixes. Or they're objects that just hold data, just basically DTOs. And they're just little buckets of attributes, which, you know, there's nothing wrong with that, but sometimes when people have too much of this style, what they find is that they end up with a slightly peculiar way of looking at the world. They end up with some very strange object responsibilities, validators and checkers and things like that. These are not things, these are kind of made up. But I think one of my favorite observations was somebody, when I was running a session on test-driven development at a conference, I had somebody come up to me afterwards and he said, Kevlin, should I have tests? You know, should I write unit tests for all of my classes? And I said, well, you'd have to write unit tests for any if you don't want to. You know, there's no should. There's no police coming around to check on your code. But if you've agreed that you're going to write things, then maybe you should consider it. They said, well, what about all those really simple classes? The ones that just have data, that just are getters and setters. Should I write tests for those? Now, sometimes when people ask you questions, what you realize is they're not asking you the question they think they're asking. They're asking a different question. And I determined very quickly, I said, well, so your code, how much of it is getters and setters? Oh, most of the classes are just getters and setters. Okay, so A system that is just getters and setters doesn't do much. You know, it just sits there being getters and setters. I have some data if you want it, but you know, you have to ask me for it. You can set it if you want, but you have to tell me to do it. But surely, who holds it all together? So I asked him, where's all the logic? And he said, oh, that's in these really big controller classes. Do you have tests for those? Oh no, they're too difficult to test. So basically we have these monstrous, tightly coupled managerialist things, and then these disempowered workers who aren't actually working at all. They're just sitting there holding data. And these are too easy to test, and these are too difficult to test. So please, can you tell me that I don't need to write tests? That's what he was basically saying. And we've ended up with this kind of crazy start. So managerialism is what most people have ended up with. So we need to kind of get in there and start, first of all, understanding the role that our object should be playing. And some of our naming habits are interesting because a name will influence the way you think about something. When you choose a name for something, you are not merely labeling something, you are actually placing a model in somebody else's head. And they will follow that model. If you said it's a manager, then what are the boundaries on management? There are no boundaries on management. There's no cohesion to that concept. So when you wonder why is this class 10,000 lines long, it's because it had a bad start in life. Somebody called it manager, or they called it controller. What is in a program with control flow, what do you have? Lots of control flow. What does a controller do? Well, they control some of it. Okay? And you suddenly discover that you end up with these anemic model objects. You end up with all your business logic hiding in the controller, and then you wonder why we can't maintain it. So here's an idea. One way, to name classes, to give each a unique name, indicative of its purpose. Unique names give you the opportunity to convey a lot of information without creating names that are long and unwieldy. Can you find a name for the thing as it is? This is exactly the right thing to do if the names are in common use. So, just to illustrate why or how we can end up with this really strong influence, I'm going to take a workshop example that I use. This workshop example is quite simple. It's a conventional book lending library, and you think, well, this is fairly straightforward. I've had people go all the way through to code and tests with this one, and you have the idea of a member of a library can loan a book copy. They can take out a loan, and the loan is maybe 4 weeks or something like that. So there is some kind of relationship. A member can have many loans. I'm not worried about the numbers, and a loan is against a book copy. A book copy can be loaned and against a member. Great. Now, sometimes people look at this and they go, oh, you know what, we need to decouple this. Everybody, these are all concrete classes. Everybody seems to know everybody else. That's too much information. We need to factor out interfaces. So we'll have member as a concrete class. We'll have book copy as a concrete class, and we'll leave these as interfaces. So therefore the loan now characterizes a relationship. Now we have the interesting question, what do we call these boxes? And this is where people kind of go, oh yeah, they reach for their nearest naming habit. They don't even know they're doing it. This is the whole point about habits. Habits are invisible. You don't even know you're applying them. So there's one. Okay, so this is classically a Microsoftism, but it's crept into the Java world. Thank you, Eclipse. And it's just that I've solved the name clash problem, because that's how people have come at it. It's a name clash problem, that's what it is. No, it isn't. What we've ended up doing is we've simply showed a remarkable lack of imagination. Nobody likes to be told that. What we've done is we've said, I've got a member, right, I'm going to extract an interface. What are we going to call it? Oh, it's a naming problem, just put an I on front of it. Okay. Now, there's a subtle thing here. You don't know you're doing this, but there's an alignment. You look for things that are similar. You match them up. Without realizing it, what you've got there is a vertical alignment. You're grouping things like this. You are saying members and I members, book copies and I book copies. That's how to think about this model. And then there's a loan that glues it all together. No, it's completely the wrong way to look at it. Sometimes people will package these together. They'll package a concrete class together with the interface, which kind of misses the point of the interface. The correct way to look at it is like this. A layered view. A loan defines a relationship between two kinds of object. There are two implementations that we can plug in, but you know what? They're not important. How do I know they're important? Because they're down here. I can take them away and replace them with mocks or or new versions. They're plug-in. The most important thing happening in the diagram is not left-right, like that. The most important thing is the fact that alone is a relationship between two kinds of things. What is that relationship? It's a role relationship. What is the role that thing plays? Is that actually a member? Is that actually a book copy? What is the role that it plays? What is the part that it plays in this relationship? What you're actually trying to do is explore a relationship. Now this is one of the ironic problems of object orientation, is people get obsessed with the object. Actually, most things in object orientation are about the relationship between the objects. What is that relationship? How do we talk about it? So, you know, there's this idea, a person or a thing's function. Is that thing a member? Is it actually functioning as a member? A member has a name. A member has an address. A book copy has an ISBN. It has a title. Are these things actually important as part of that relationship? It turns out they're not. Now, the strongest one is on the left, borrower. Borrower is someone or something that borrows. It could be a member, perhaps it could be another library, perhaps, I mean, it doesn't really matter. A borrower is not something that necessarily has an address or any of these other details. The point of view is that a loan is against a borrower, and this is where unfortunately we end up kind of with loan item, even though we don't want item, because loanable, maybe that's okay, but there is a little bit too much adding able on the end of things. And borrowable is not, yeah, it's hard to say in English even when you're sober. It doesn't really quite fit. So on the right hand side, I'm not too attached to that name, but it's a start. Because what you've said is it's nothing to do with book copies. A loan is an arrangement between a borrower and an item that is loaned. That is what a loan is, and you'll notice that horizontal alignment. You've described the relationship. Whereas normally people say, I've got a concrete class, let's pull off all the methods, and they focus on the problem in the wrong way. Now, here's the thing. This whole naming habit of putting eyes in front of things that people sometimes do, really, we've got a thing called interface. It's a big clue in the language, and so therefore I'm also going to say, if you ever call a class abstract something, I will find you. Because I know that it's abstract. How? Well, there are a number of little clues, like the keyword abstract. There's also the fact that it won't compile if you try and instantiate an abstract class. Why won't this compile? Because it's abstract. You're trying to create new of abstract thing. That's not allowed. And so therefore what you've done is, unfortunately, without realizing it, is you've missed a really good opportunity to name what it is. You've just said, here's information I already have. I'm going to tell the reader just in case they're really stupid. I mean, maybe I should put the word class in just to be really helpful. And all my methods will be called something about a method. You know, just to make sure that you know that it's a method that you're calling. Maybe I should label all my variables variable as well, just to be sure, because people might get confused. So, no, just go with it, okay? If you're struggling, and that's the thing we do, we don't realize we're doing it, we reach for a naming habit. Oh yeah, here's a space, I'll fill it. Okay, so let me pick another example from a different workshop. And this one is interesting because it makes it even more obvious that if you get the right name, you identify the right role. Or if you understand the role, that will help you find the name. And if you understand the relationship between the role and the object relationships, what you end up with is less coupling. Now sometimes people think, well, that's crazy. How can you end up with less coupling just by realizing the role it plays? Well, quite easily. So here's another one that I use. So here's a problem. People are taking in some text. They're supposed to parse it and produce basically a build tree. Oh, sorry, a simple parse tree. Often people will introduce a builder in between to help them. So here's a parser. It sends events to the builder. Hey, guess what? I've just encountered the beginning of an array definition. Okay. Oh, look, this is a string. Oh, look, I've just encountered an integer. So basically, the parser will do all the recognizing work. The builder is going to do all the building work. You know, the object, the roles seem really well defined. And then when you're done, you can say, right, builder, how are we looking? Give me the tree that you've got. That seems very reasonable. So, sometimes people say, well, the builder, yeah, it should really be a plugin type thing. Maybe I want to mock it as well. I want to check that the parser is giving me the right events, it's seeing the right things. So at this point, smug and happy with the fact that we perhaps don't use the I prefix convention. So, I never do stuff like that. No, I do this. We put impl on the end. It's just like, no, that's exactly the same practice. It is exactly the same practice, just in a different place using different words. But effectively, it's the same idea. Instead of naming the interface, we've chosen to say, you see this implementation class, it's an implementation class. Just in case you struggled with that. Now, there's an interesting consequence here, because when we look at it and we think about it, we've got the same vertical alignment again. We've said the most important thing about it is it's a builder. If I actually hand roll a mock, what am I going to call it? I'm going to call it a mock builder. But if I start looking at it closely, the one thing I'm going to realize is that it's not a builder at all. It doesn't build trees. The relationship, what's that relationship? There's a relationship here between a parser and something. So, as a colleague used to call it, there's an interface, but think of it as an outer face. There's a two-part relationship. There's a parser and something. It's not parser and then there's this other thing off to the side. There is a unified relationship. A parser cannot operate properly without maybe a parser listener. Parser handler if you want, but listener is a little more conventional. What is a parser listener? Well, it listens to parsers. Great. So therefore it handles events. Brilliant. What's it doing talking to a tree? Well, what's anybody in life doing talking to a tree? You have to drink quite a lot before you want to talk to a tree. Parser listener, what's it doing talking to a tree? Well, that's not its role. Its name is so precisely scoped. Its role is so clear. Parsers, plug in a parser listener. Well, it could be a builder, but it could be anything else that happens to be interested in this stuff. It could be some kind of logger. It could even be a generator. You could even have a round trip. The parser listens and then sends to something that automatically generates the same thing, or generates it in a different language or notation. But trees, nothing to do with parser listeners. That's not their responsibility. It's a builder responsibility. It moves it down there. So what is interesting, and perhaps not as obvious when you go back to the library example, is exactly the same thing happens there. You end up with narrow interfaces, because what you're trying to do is the really hard thing. You're trying to find out, what is this thing? Part of that is in the naming, but sometimes you're pushing for the role. If you're coming at this from a mock object perspective, there's one of the early but overlooked papers on mocks is entitled Mock Roles, Not Objects. It's published in 2004. And that's really it captures everything. The idea of mocks is that they capture an aspect. How are you using this object? What relationship is it? Whereas normally we come at things and say, we've got this huge, great API. We must mock it all. No. What's the relationship? And that's a very different question. So it turns out that most stuff about objects is actually about relationships. And when you understand that, then the names come out. So, you can communicate how the new class is the same by naming some superclass. It need not be the immediate superclass if some distant ancestor communicates more clearly. So, we'll see an example of that. You can communicate how the new class is different by finding a word that accurately highlights the reason the new class isn't just a superclass. Let's have a look at that. Okay, so here's a failed version. We've got a connection. We've got a connection factory that creates connections. We've got a connection impl that implements connections, and the connection factory knows about the connection impl, so it can pull them and recycle them. Let's try that one again. We've got a connection pull. Better. Most things that are factories should not be called factories. Okay? Factory is a role, certainly, but it's not the only role something should have. So for example, you'll notice nowhere in the Java APIs is there an interface called iterator factory. It's iterable. And you have collections. Are they iterator factories? Well, that's where you get iterators from. We don't call them iterator factories. Hey, you pass an iterator factory into what? No, you pass a collection. It has a factory responsibility, but the responsibility is not the same as the name in that sense. So a connection pool and a pooled collection, that's the name of the thing. It is a pooled connection because it is associated with a connection pool and it satisfies the interface of a connection. So we differentiate it based on the prefix name here, but that's a kind of secondary naming pattern if you can't find the real name for the thing as it is. We also have another set of naming habits. They go all over the place. So create, that's another prefix we like to use, because obviously it's obvious that's what we're doing, we're creating it. Create connection, I've got a provider, and then, oh, thank goodness that Java is a case-sensitive language, because all I have to do to have my parameter name is just lowercase the first letter. And now I can have a provider argument that's called provider. Brilliant. And here, although I'm not a fan of checked exceptions, I'll do one here because it allows me to keep it on the slide. Connection failure exception. We don't even know we're doing this stuff. Oh, what is it that we're doing? Okay, nobody wants to create a connection. I'm at this point in my code, I need to create a connection. No, what you want to do is you want to connect to. That's what you want to do. Think about it. What are you trying to do? I'm trying to connect from here to there. Now, creating a connection is a way of doing that, but that fulfills your desire. Your desire is to connect to. The problem is we've ended up programming in what we might call object-oriented assembler. Yeah? Object-oriented assembler, what does that look like? Well, get, set, create. These are all really low-level concepts. They don't actually capture your intention. Whereas here, I want to connect to a provider of updates. Oh, damn, that even reads well. And I committed the ultimate heresy, for which you will probably throw me out of the building for, is I took away the exception from the end of the word connection failure. How will I know that that is an exception? The name failure does not give me any clue whatsoever. I mean, it could just be an ordinary variable. I mean, connection failure, what could that possibly mean? In a throws clause as well. I mean, I have no idea that this could be an exception at all. And it can only appear. It's the only kind of thing that can appear in a throws statement and in a catch. You know what? They're so important, I need to put the word exception on the end. Let's go back to that idea of let's put variable on the end of all those variables, because you just don't know. Yeah, you just don't know. An object on the end of everything. No. So, sometimes it's invisible, we don't even see it. And it does, it just makes the names longer. We emphasize something, possibly the least interesting thing we could say about an exception class is that it's an exception. Yeah? And you can actually tell this, you can go through the library and you can see all the really good names. Okay? Illegal argument, exception. Take away the word exception. Illegal argument. Oh, that's actually delightfully short and totally descriptive. Yeah, it's not an exception about illegal arguments. It is an illegal argument. That's the idea, is that with object orientation, sometimes we take too far of a step back. We've ended up kind of, well, that bit in the matrix. Stop trying to hit me and hit me. Actually name it for what it is. This is about an illegal argument. Let's have that conversation. Okay? Rather than this is an exception that I'm going to tell you about an illegal argument that once upon a time I met. No, that's not interesting. Okay, so let's dive deeper into this. We've got the idea that roles are important, but what about the objects themselves? What about the dynamics of this stuff? Alan Kay, inventor of Smalltalk, or one of the inventors of Smalltalk, made the observation, you know, object-oriented programming to me means only messaging, local retention and protection and hiding of state process, and extreme late binding of all things. It can be done in Smalltalk and Lisp. There are possibly other systems in which this is possible, but I'm not aware of them. Yeah, he tended to be quite, you know, he tends to be quite forceful on his view of these things. So let's have a look. What kind of thing are we talking about here? There's an observation by William Cook in a paper he published about 5 or 6 years ago about revisiting a paper that was published in the 1980s about polymorphism and data abstraction. And he said it is possible to do object-oriented programming in Java, which is one of my favorite quotes from his paper. So let's find out. Let's talk about the big three of objects. Now sometimes people think, when you say the big three, they think, oh, you mean encapsulation, inheritance, and polymorphism. No, I mean ignorance, apathy, and selfishness. Ignorance, don't know. Apathy, don't care. Selfishness, it's all about me. Why are we talking about you and what you are? It turns out, if you apply these three, you end up with a really good object model. Okay? Okay, that object over there. I wonder how it's implemented. I wonder if I can get any collections out of it. Oh, people love passing collections around. Yeah? And actually, no, you shouldn't know. Yeah, but I really want to know. You shouldn't care. Okay, you need to focus on your conversation. What is it you really want? In other words, it's not create connection, it's connect to. It's what service do I want from that? It turns out that in a number of cases, if you take, and this is something that, for example, that tests can help us with, if you take a very egocentric, selfish view of an object, put yourself inside that object, and instead of looking at some huge, great interface, somebody said, oh look, I've got this really rich class filled with methods and possibilities, and you can use it. Instead of doing that, you turn it around and say, thanks, but I'm not interested in all of that. What I really want to do is, and you narrow it down. So back to the library book example. What kind of question does the loan want to ask the member? Because I used to always put, with that workshop, I always used to put rules on. You know, you can't borrow more than 6 books at the same time. Okay? And only certain books can be borrowed by certain people. So if a child cannot borrow certain books. Maybe you can't borrow any books if you owe too much money to the library. So you've got all these possibilities, and what I'd end up with is that people would have all of this logic inside the loan, and the loan would be saying, right, member, how many books do you have on loan? And how much money do you owe? And, well, these are very personal questions. Okay? But actually, let's take it from it's a very busy class. Actually, what does it really want to ask? What's the selfish question that makes its life easy?
Can I borrow?
Yeah, exactly. Can I borrow you? If the answer is yes, we're good. True, we go. False, we stop. It's as easy as that. It's an inversion. People often misapply the use of the phrase inversion, but it's an inversion. It's kind of like, I don't want to have this conversation with you. Can I or can't I? Is this a yes or a no? Oh, look, I've got a really interesting detail. No, that's for your implementing class to deal with. Actually, me, I couldn't care at all. I don't want to know. I want to talk about me, because I want my code to be simple. I want one line there. I don't want 4 or 5 lines with ifs and all kinds of crap. So this is actually one of the other ways that you make the thing simpler. You push it around. You actually turn the whole thing around and say, well, what conversation do we want to have that is really selfish from this object's point of view, but makes its life simpler? And just to be very, very clear, this is for code, not for people. Okay? Just don't walk out of this room misapplying this. Okay, let's talk about another big 3. How do we characterize what an object is? What differentiates, for example, traditionally objects from, say, functions or components or whatever? Identity, state, and behavior. This is the way that Grady Booch always characterized an object. That allows us to distinguish between paradigms. Basically say an object is a thing I can refer to. It's that thing over there, not that thing over there. It's got state. It has some kind of value content, although what we'll learn is that can vary, and it has behavior associated with it. But this is not always equal, and so one of the things we want to do is explore this a little bit, and I'm going to pick on here's a pile of books all about objects. Granted, they're all about the psychoanalytic theories to do with objects, so I'm not interested in that. What I'm actually interested in is the fact that this is a stack, and the stack is the lab rat of computer science. It is the basic ingredient that anybody's going to do. So I'm going to have a stack here because that's fun. Because it turns out most people don't know not how to implement one, but how to test it. We're going to get to that. So it's a stack. So how do I characterize a stack? How do I talk about a stack? It's one of those commonly used object examples, but let me take a slightly different approach to this. A stack has a set of operations. I'm going to keep it really minimal here. I'm going to say push, pop, depth, top. That's it. How do I talk about these? Well, I can go a little bit further and I can say, well, look, these things are operations that have signatures associated with the stack. I can make it generic. I can say, look, you push something of type T, you can pop. It's a pure pop, by the way, this one. It doesn't return anything. If you want to get the value at the top, you ask for top. If you want to get the depth of the thing, its size, you ask for depth. That's it. That's all we've got. Okay, so I'm going to keep everything really, really simple. How do I talk about its behavior? So some objects have very, very rich behavior, very detailed behavior. Some have very boring behavior. Some objects are immutable and their behavior is a direct derivative of their state, and that is it. They're quite boring to talk about, but surprisingly useful. I'm not going to make stack one of those. I'm going to actually make stack a little more interesting. I want to have some interactions, and I want to answer questions like, can you pop an empty stack? What happens if you do that? So this is interesting. So what we're after here is something beyond the signature. A very good paper published in 1983 by Butler Lamson, Hints for Computer System Design. There's a lot of this paper that still reads as being quite fresh, quite informative. And he makes the point, he says, an interface is a contract to deliver a certain amount of service. It's interesting. It's interface as metaphor, as a way of describing the relationship between somebody using something and somebody supplying the implementation. So the idea of the contract metaphor is really good here. In other words, it's more than just signatures. It's not just a type signature. That's part of your contract, but it's not the whole of the contract. Now, he then goes on to say, clients of the interface depend on the contract, which is usually documented in the interface specification. Oh well, that's the bit that makes it look like 1983. Yeah, everything else is pretty good. Okay, so how are we going to do this? Let's go for another view. The person who popularized the idea of contract approach was Bertram Meyer in his book Object-Oriented Software Construction, which, as you can tell, was published quite a while ago, just by the cover style. And his approach was very much based on pre- and post-conditions. And this has, a lot of people get very excited about pre- and post-conditions. I know I did when I first encountered them. And so what we're going to do here is we're going to take the stack and we're going to annotate its behavior. Given, we're going to say, we're going to introduce a dummy variable, a value. Before is depth. The post-condition, once you've done a push, the post-condition is that the depth is equal to whatever it was before, plus 1. And the top value is now the item that you pushed. That seems a reasonable contract. Top, given before is equal to depth, and we're going to throw in a precondition here. It's got to have depth. Yeah, it's got to have a depth of greater than 0, because otherwise we've got nothing to push. Pop, sorry. The post condition is that the depth is 1 less than it was. We're just getting to the point where this is not a very good contract. If you look at it, it's just like, well, tell me about the stack. Well, it's 1 smaller. Can you tell me what's in it? Nope. Surely that's the most interesting thing. And when we look back to push, we realize we know what the top value is, but we don't know what the rest is. We haven't said anything about it. And then it starts getting really vague. Depth. Depth is greater than or equal to 0. Great. So what can you tell me about the depth of this stack? Absolutely nothing, except that it's not negative. Wow, this is a pretty bad... Look, this is... If we restrict this from being the domain of all integers to being the domain of int, I've just basically said depth will return you any one of 2 billion values. Well, that's quite a broad range. Yeah, maybe only one of them is right. How do I know which one? What we're missing here is a historical context. History and state. We've got no proper historical state model here. And when we get to top, it's useless. Precondition. You can only ask for the top if there's a depth. What's its value? What does it return? I have no idea. I can't tell you that because within the interface, I cannot specify the contract. So the pre- and post-condition model, it turns out works really well for some kinds of classes, but for most kinds of classes, it normally has some kind of problem. So it's actually quite a limited model. Let's try a different approach. Let's take another book that comes from that series, Tony Hoare's Communicating Sequential Processes, which is not obviously to do with what we're talking about. What he was talking about was objects, or rather processes, that had encapsulated state and dealt with messaging, and they had history. And you want to be able to talk about life cycle, so they have a life cycle model. That's what we want. So let's use some of his vocabulary and simplify it a bit. The alphabet of a stack. Put another way, or maybe alphabet or vocabulary. What can a stack talk about? What kind of conversations can we have with it? Well, I don't know what kind of conversations, but I can tell you the words we're going to use. The ingredients, the primitives are push, pop, depth, and top. If I want to talk about what the conversations are, then you can describe a trace. Okay, a trace is the set. The set of traces is the set of all possible legal call sequences that don't result in this case, an exception. So the first one there is an empty sequence. You can create a stack and then ignore it. Yeah, leave it to the garbage collector. You can create a stack and then push onto it and then never talk to it again. You can create a stack and ask for its depth and never talk to it again. You can create a stack and push onto it, pop from it, and never talk to it again. You can take a stack, you get the idea. There's an awful lot in this ... If you have any junior programmers, give them this. Yeah, we just want you to expand this here. Actually, it turns out that you're not, with traces, you're not really supposed to just sit there and write out all the legal possible sequences. We've got things like state models for that, which makes life a lot easier. Okay, and we have various syntax forms. I've used a graphical one here, but there's different approaches. And now what we've got is a much richer model. You create a stack, it's empty. You push onto it, it becomes non-empty. Okay, you can always ask for its depth. You can ask for its top in the non-empty state. You can't ask for its top in the empty state and expect ordinary behavior. You can pop it in the non-empty state. If the depth is greater than 1, it'll remain non-empty. But if the depth is equal to 1, it becomes empty and you can't pop it. So here, we've saved the junior programmer a lot of work. We've now generated all the possible stack sequences. Oh, this is great. There's only one problem. You'll notice this doesn't look anything like Java. And there's this question sometimes, oh, we need more graphical programming. Actually, there's a different way of expressing the contract that will survive in the code and give us some value. We can create a set of tests. Actually, the original motivator for my stack example was I keep seeing stack examples badly tested in books. So I was finding, right, let's do one that's actually decent. Let me just rearrange the syntax a bit and then drop out all the rest of the words. And what we find is we're going to use behavior-driven development terminology. I'm going to call it a stack spec. And then I've got a structuring, so I'm using nesting, which is perfectly legit in JUnit. I'm going to say, right, a new stack has 0 depth. A new stack throws when queried for its top item. An empty stack throws when popped. An empty stack acquires depth by retaining a pushed item as its top. A non-empty stack becomes deeper by retaining a pushed item as its top. A non-empty stack on popping reveals tops in reverse order of pushing. What is important here is not only the terminology is exactly right, is describing this, but this is a set of tests. It will show you by example the history that we were missing in the previous one. I can show by example here. Look, I'm going to take Tom and Jerry, and I'm going to push them both onto a stack, and then I'm going to pop them off in reverse order. That's what's going to happen. And I can show you exactly that because the unit of contract now becomes the whole example, not simply the relationship between the operations and the interface. So this takes us a little more deeply. So this gives us a better sense of this is what we mean by behavior. Now, what I want to then do is I'm going to leave out a discussion of value objects, interesting as it is, because I want to jump to this bit where I want to talk about encapsulation. The other big three, encapsulation, inheritance, polymorphism, we always do them like this. I'm not entirely sure why, because it turns out that the right way to do it is this way. And people are sometimes thinking, well, hang on. When I learnt how to program, maybe how I learnt to program in Java, how I learnt to program with objects, we were taught encapsulation, make stuff private. What's the point of encapsulation? The idea of encapsulation is that you don't know what the implementation is. I'm calling something and I do not know, and I do not care what its implementation is. And I can narrow my focus down to its interface and be quite selfish about what I want from it. So the usage defines the interface. And then you learn about inheritance, where somebody says, hey look, you can have 2 classes and they might share some common implementation, so let's save a bit of time. And then you learn, by the way, if you've got inheritance, you get this thing called polymorphism, method overriding. Let's turn it around. Inheritance is just a mechanism for code sharing and enabling polymorphism. The real interesting one is polymorphism out of those two. Because polymorphism, it turns out, is like encapsulation, because what's the point of polymorphism? It allows you to call an object without knowing how it's been implemented, and it will do the right thing, and you don't have to care how it does it. So in other words, polymorphism is a thing that's of interest and is kind of an encapsulation, whereas inheritance is just an enabler. It's a mechanism. And the most interesting inheritance is interface-based inheritance, or pure subtyping. So, yeah, these are not all created equal. In fact, if we were to shade them accordingly, that's how you should kind of consider these features. And particularly if you move to languages that are dynamically typed, the support that inheritance provides for polymorphism is almost independent. It's less relevant. So, encapsulate tells us something deeper. It's not just keep stuff private. If I look it up in the regular dictionary, it says enclose something in or as if in a capsule. No reference to programming objects, but does refer to capsule, which is good because it's got the word capsule in there. To put in a capsule, that's what encapsulation means. And a capsule has a boundary, has an inside and an outside. And that's the emphasis there. Express the essential feature of something succinctly. This is abstraction. The essence, what is it? It's right back to that naming it. What is the essence of this thing? What's it here for? So it turns out encapsulation is not just keep data private, it's a much deeper and richer concept. Provide an interface for a piece of software to allow or simplify access for the user. That's the idea of the selfish user. The user is selfish. They don't want to care about all this detail. Just make it easy for them. So we end up with a much deeper vision here. Now, there is this question though, about interfaces, about inheritance, and subtyping, all this kind of stuff. And a number of years ago, I was very interested in this kind of stuff, and I came across a researcher called Pierre America who worked at Philips Labs in Eindhoven. And he made this observation. He said, in many object-oriented programming languages, the concept of inheritance is present, which provides a mechanism for sharing code among several classes of objects. Many people even regard inheritance as the hallmark of object-orientedness. We do not agree with this view and argue the essence of object-oriented programming is the encapsulation of data and operations in objects and the protection of individual objects against each other. Okay, so that's a much harder view. In other words, this idea is not new. This paper was written, it's a report published at Philips Labs in 1991, I think. Okay, he's not alone in this. The author considers this principle of protection of objects as the basic essential characteristic. It is a refinement of techniques of abstract data types, because it not only protects one type of object against all other types, but one object against all other ones. Now that's interesting, and what's really interesting is as a programmer we can consider ourselves at any moment to be sitting in exactly one object and looking at all the other objects. This is a really good way of thinking about your code. You normally look at your code through an IDE, through an editor, because you can see everything. Imagine you couldn't see everything. Put yourself in one. What can you see? And it turns out that what you want to see is as little as possible. How does that look? Yeah? Whereas normally we get a flat view of everything. This is a very different view. So in this book, which is surprisingly unreadable, A Theory of Objects, I think it's got 5 or 6 chapters, one of which is written in English, and the others are written in Sigma Calculus. I read the one in English. It was fine. They make this object-oriented observation. It does not have an exclusive claim to all these good properties. Systems can be modeled by other paradigms. Resilience can be achieved just as well by organizing around abstract data types, independent of taxonomies, hierarchies. Okay, so what do we mean by abstraction? So what I want to do is I want to talk by looking at the slightly more theoretical side of what's really going on here. My dictionary of mathematics gives me this, whoa, major definition. Process of formulating a generalized concept of a common property or disregarding the differences between a number of whatever. An operator that forms a class name or predicate from any given expression. Okay, they're not talking about objects, but it's close enough. It allows me to get away with adding in getting away in a Java talk with the use of an upside down A and a back to front E. So that's a win. It just allows me to get away with that. What are we saying here? Let's translate this. I'm done with stacks. Let's move on from stacks. Let's talk about recently used lists. What is a recently used list? It's like your recently opened files list. So therefore it has stack-like properties. The most recent item goes into the head, but it also holds its elements uniquely. When we think about unique, that's important because what we're saying is a bit like a set. When you add in an item that's already there, it moves to the head instead of occurring twice. So what does this say? Let's translate it into English. So it's generic for all types T. There is something called a recently used list such that it's a record of possible fields, a Cartesian product. New is empty, size, get, add, equals, and then we get this kind of whole set of signatures as to what you get. I'll skip that. Let's just flip that back into Java. Okay, we're not worried about the private stuff. We've got is empty, we've got size, we've got get, we've got add, we've got equals. I presume we've got a default no-R constructor. Then we end up with a slightly curious thing, because if you look at this, you suddenly think, hang on, that's not right. He's got a problem there. That's what it should be, plus an at override. Actually, there's a reason these should be different, and that reason becomes apparent as you start walking through. First of all, are we saying, given that I've just done this using a class, is object orientation the same as an abstract data type? We'll say, no, it's not. It becomes obvious when we start flipping through this. Back to the William Cook observation, he says autognosis, which is another great word, like linguistic morphology derivation. An object can only access other objects through public interfaces. It's a really strict rule, what we're saying. This is different. So let's go and have a look. Let's have a look at these two implementations. If I compare against another recently used list, then I check that I'm not null, or it's not null, and then I can just say, go ahead and use the equals on the underlying list, the internal list items. If it's the polymorphic version, then I need to check it's the same type as me. There's a few other things I could do, but I've left them out. It's the same type as me, and then if it is, then we can go and reuse this. So this does field comparison, and this does instance then field comparison. Okay? Right. So why is this not actually object-oriented? It's not object-oriented because if you look here, we assume the internal content. We assume we can see inside another recently used list. You probably don't even know you're doing this. It's become so background, I didn't know, I noticed I was doing it. You're an instance of my type of thing, therefore I can know about your internal implementation. Oh, okay, that's cool. So let me just mess about with your internals. That's really gross. But what we're saying here is there's a difference. And there is a reason that we have this feature in statically typed languages. You don't get it in dynamically typed languages. And that is efficiency and directness. It's a compromise because the alternative is to do it like this. You have to go through every element, because actually I don't know that I can access your private fields. I can't talk about that. I can only do it through your public interface. So I can do it as a restriction. Then William Cook also, I remember I was reading this and I was glad that I was sitting down. One of the most pure object-oriented programming models yet defined is Microsoft's Component Object Model, COM. It enforces all of these principles rigorously. What? What? You are kidding me. Programming in COM is very flexible and powerful as well. There is no built-in notion of equality, and there is no way to determine if an object is an instance of a given class. If you think about it for a moment, asking an object what its implementation class is an incredibly personal question. And it's not much different to saying, hey, look, I want to see your fields. Because the whole point is I should be using it polymorphically. Oh, there's a set of things I can talk to you about. That's great. But, by the way, who are you really? I mean, you know, really? No. So what that means is that that little instance of check knows. And it turns out, actually, we don't really want to check these objects like this at all. So actually the problem's simplified. We just get rid of the polymorphic one. That was easy. And just say, you know, you only got reference equality. If you want equality, you must know that the other thing is of the right type. And then you do this. And it's kind of like, oh, this is not really what I signed up for in terms of objects. But it is the purest view. Yeah? You do not get to take advantage of those things that have been abstracted away. That's what they're saying. So I'll skip that. So what does this mean in practice? Let's pull this one back to somewhere that we can actually take something useful and code it up. The observation here is that if you want a pure object model, as opposed to what we normally program with, which is a hybrid object ADT model, the object-oriented subset of Java is a class name occurs only after new. In other words, you only ever use an object polymorphically, strictly, through an interface, and then you only ever use the class name to create it. The class name is only ever a description of an implementation, and that's it, and you plug the two together. Now this is quite a strict definition, but nonetheless there is use in it. So that's the interface. There's an implementation. Recently used list impl, not keen on that. So we could call it after what it is. Name it after what it is. What is the thing that is characteristic about it that you would like to tell other people? Maybe it's the fact that it's based on an array list. I'd prefer to say that it's a random access recently used list, as opposed to one that takes linear time to do its operations. It doesn't really matter, because the idea is that in your code you will only ever be accessing it via the interface. At the point of creation, that's why you can have long creation names, because you only ever use them once. Yeah, they either appear in a new expression or hiding in an XML file somewhere, but that is it. That's the only time they occur. Everything else is used strictly through an interface. And that's quite a discipline. That's the reason we don't do that, but you'll find out that it's quite useful. So, bringing it sort of towards the end, and also unifying a multiple set of paradigms, William Cook made the observation that lambda calculus was the first object-oriented language. And he dates it 1941. Actually, it was 1932. So I think it's really great that Java 8 gives us the ability to program like it was the 1930s. That's really cool. We're catching up there. Eventually, we'll reach the 1960s, and who knows what will happen? Revolutions. Yeah. And here's a way we can describe it, because what it is we're saying that when you create a class, you have a lambda that captures a closure over a set of state. And that's all great fun, but what does that look like in Java? Well, I had a bit of a go at this, and I relied on Java 8, but I ended up with the idea of, okay, I'm going to have a thing that creates instances of recently used lists. So it's a supplier of recently used list. It's called new recently used list. It should be final, but I've left things like that off the slide. It's a lambda that takes nothing, and then it's got state. That's all it's got. It's got state, and so it's going to be a new array list. That's the state, the private state of the object. And then I tried doing this with lambdas, and it's a pain in the backside because it will never look right. So I end up having to use an inner class. But then what I do is I then create an instance, and you will see, and I'm not saying this is the best way, but I'm saying this is the purest way you could ever do it. I've shown you kind of a half pure way, a class attached to an interface. But what we're doing here is we're actually saying that the recently used list in a class, we create an instance effectively that is bound to that state. And there's no piece of reflection basically that you're going to be able to do to get your hands on that private piece of state. It's so private it's actually a variable. Maybe we should call it items var, just to be sure. But what we're saying there is that this gets returned to the caller. What they do is effectively they have a new instance that refers to the private state of a function or method that no longer exists. In that perfect closure, there's not a question of state. There's no kind of like, you know what, I'm going to have a look behind the private barrier. You can't. It's actually just a set of operations that are being bound together. So an object is a set of operations associated with private state. This is the purest interpretation you have. But there's a reason we don't do this. It gets messy. It gets messy very quickly, and there are inefficiencies to be done. But what it means is that we've kind of taken it to the logical end. This is what an object really, really kind of is. But what we'll do to make it practical on a day-to-day basis is we will mix in other paradigms. And I started off by saying you've got to watch out for mixing your paradigms, because we ended up thinking we were doing objects, but most of us are doing managerialism without realizing it. Yes, you can mix these things. Mix it with a little abstract data type, mix it with a little functional thinking, a bit more immutability, and you end up with a really good blend. And to recognize that each language gives us that. And so I'm not advocating that you should go for a single pure paradigm, which sometimes people do, and I think there's value in that. But if we're going to start using words like paradigm, which I have been for the whole of this talk, let's at least read the original paper. Now, he's not the guy who coined the word paradigm. That phrase, in terms of what we mean, is actually much older. But Robert Floyd, in his 1979 Turing Award speech, he referred to the paradigms of programming. It's his fault that we talk about this in software development. He was the guy that started it all. But I do recommend reading this paper, because some of it seems really old, and then bits of it seem really fresh. He says, I believe the current state of the art of computer programming reflects inadequacies in our stock of paradigms, in our knowledge of existing paradigms, in the way we teach paradigms, and in the way our programming languages support or fail to support the paradigms of their user communities. What he's actually saying is that we don't have enough paradigms to choose from, and that we should be a bit more expressive. And actually, if you look closely, he uses the word paradigm like we now use the word pattern. So what my focus here is, first of all, if we're going to start talking object orientation, and we're going to criticize it, then we should understand what it is that we are criticizing. But we should also realize how we blend paradigms to make a particular thing. The Ruby version of objects is very different to the pure Java version of objects. And there are a number of reasons for this, but each of those mixes in something that makes it attractive to its user communities. And on that note, I'll shut up. Thank you very much. So, questions? I have a man here with a mic.
How stupid that man looks like, but I'm not dangerous.
And it just occurs to me that your name is actually, if I mess about with it, it is Michael, ultimately. You know, so yeah, the man with the mic is Mike. Yeah. So me whole. Yeah. Any questions? Any thoughts?
We got one. Okay. The first volunteer to use ever our mic. Thank you, bud.
I thought about some concepts like static type language and the many conventions in the static languages. Does it change?
What do you mean, does it change?
You don't have the interface. You don't see the interface. You lose the couple of languages.
Oh, right. So if I switch to dynamic languages, then I no longer have the concept of interface.
Yeah, exactly.
Yeah. So there, what you end up with is you embrace a slightly different style or a different approach to thinking. So, for example, if you're working in Python, I'm more likely to touch Python code than I am Ruby code. But if you're working in Python, people say, yeah, that's object-oriented. It's got objects all the way through. I don't have a concept of interface. So how can I survive? What you end up with is you end up pursuing a very different style. You follow a different style. You refer to things sometimes informally by their capabilities. Oh, you say, oh, you're callable. You're this kind of thing. Oh, you're kind of like a hash. You're a mapping type of thing, or you're a sequence type of thing. So you've got this idea of being able to talk about things, but because people don't push for checking, you don't push for terminology quite as strictly. So what you're doing is you're effectively saying the interfaces are there, but they don't form part of the naming system. Or if they form part of the naming system, you're going to go about it slightly differently, whether it's by reflection, whether it's by using those names in the role names consistently. You'll use the consistency there to say, actually, I will call that variable provider because it tells me what I need to know that I did not already know. Yeah. So your balance shifts just as and that turns out to be less of an object, non-object thing than a static versus dynamic type thing. And we realize, and this is the thing that many of you may have experienced, that sometimes you think, oh yeah, I'm moving paradigm. Actually, the minute you move dynamic to static, that's actually a bigger paradigm shift sometimes than moving from a non-OO to an OO language, depending on the features of the non-OO language. So that's another axis. But yeah, your conventions will support it differently, and you will end up with a different blend, as I suggested before. Yeah. Any other questions or thoughts? Or objections, observations? I'm open for everything.
Okay, have you ever tried to write an app in a way without the new keyword, like Java style, only calling the functions, like in your example, with hidden implementation, like big enterprise system?
Now you see, we were doing really well until you said big enterprise.
Like something good magic.
Can you? Okay, so here's the question. Let's rephrase this. Could you actually use this style consistently? Yes, you could.
Okay.
It's just the question of, will you, because of expected convention or because of legacy? Now,
I more wonder, have you ever had an experience with a team where you were able to push the style on them, or they embraced it for long enough without really staring to enterprisey kind of...
Yeah, as close as I've got is, okay, things I have successfully done is got people to program to an interface with a corresponding class name. I've never got them to do the kind of the whole lambda-y type thing and hide everything away using local method state rather than actual class-based object state. I've not convinced anybody of that yet, and I haven't really pushed for that one. I don't feel the need for that. I just want to show people what it looks like. But yeah, a much stronger interface-based style, yes, that has been successful. Better naming approaches and avoiding some of the pitfalls, yes, that has been successful, but you do kind of need to watch out every now and then because people do kind of, they lapse. It's easy to do. But yes, that becomes something that people get into the habit of. In fact, they start seeing their old naming style as being uncomfortable and actually demanding too much of them. In other words, their old names suggested wider interfaces. And once you get people thinking, I'm showing you a technique here to write less code. When you sell it that way, some people go, oh, I hadn't thought about it like that. Fewer dependencies. Yeah, this is good. So yes, pushing them down that road, that has also been useful. And likewise with the testing as a way of thinking. Yeah, that. But
that's a cool way of testing, by the way.
Yeah, well, it's one of those things of like really saying what you mean. You have to kind of cut across and say, well, testing is the thing that I do when I run it. What is it that I try and do when I write it? I try and express its meaning. It's that abstraction idea, the encapsulation. What is the thing? What is the user interface to an object?
The indents, they look like in the IDE results of running a test, so it's consistent, I guess.
Yes, it is. Yeah. So there's a close correspondence there. The idea is what I'm doing is I'm listing off the capabilities, the properties and behaviors of something when it runs, and I'm choosing these as my naming structure. And so that really is, to put another way, any paradigm is one of the things that it can do, and object orientation was one of the first to really try and push this as a main idea, is to be a system of meaning and to offer people a system of meaning. Now you can do this in any paradigm, but when people talk procedural or even relational and historically even functional, people weren't saying, I'm going to offer you a system of meaning. Object orientation came about because originally in Simula and then in Smalltalk, it was the idea of I'm going to offer somebody a system of meaning. Not merely a system of execution, but a system of meaning. So that testing style reflects the idea. Yeah.
Thank you. Other questions? Sorry for stealing the mic.
Now that's it. So you're all just so stunned, or you're afraid that I will actually answer your question if you actually ask it.
We just all booked that. Okay, thank you.
Thank you very much.
Okay, promised raffle. By the way, the talk was about software craftsmanship. Thing you need to know is that Kevlin was on the conference whole day, so you just seen how the public speaking craftsmanship is like, which is